Hello and welcome to this new chapter. Here we'll be learning about differentiation. Rather than reading this boring list of topics that I've got here for you, I thought I'll inspire you with telling you how is differentiation actually applied in real life and some examples of where it's actually used in the industry. So, let's just imagine that, well, you might not have even heard of differentiation. So let me give you a definition of differentiation and integration is that they are two sides of the same coin. They are opposites of each other and they are both parts of calculus. It means basically calculating a rate of change. Differentiation uh, of a function means that finding the rate of change function. All right. So, and integration is the opposite of that. All right. So you realize their definition in more depth as we talk about them separately. So let's just imagine that you have a thermostat and you set this thermostat to 70 Fahrenheit, that's degrees Fahrenheit, and you want it to stay at that point there. So what does the thermostat do? It will turn on the heating, and once your room temperature goes above 70 degrees, it will probably overshoot that 70 degrees by 2 3 degrees before the thermostat realizes, oh, it's gone far, it's warm enough now, and it turns the heating off. And then after a couple, maybe 1 hour or so, once the thermostat, your room temperature falls below 70 degrees and maybe gets to 67 or 8, then it turns it back on again. So as this graph shows here, there is a fair amount of overshooting and undershooting of the temperature of your room, and for human desirability, that's not a big deal. Okay, we can tolerate 1 or 2 degrees of temperature here and there to our desired effect. The overshooting and undershooting isn't gonna upset us too much. But let's say you are an engineer of a nuclear plant and or an engineer of a chemical plant where these oscillations are not acceptable. Do you think that if you are running a nuclear plant or a chemical process, the tiniest divergence from the desired temperature will have disastrous consequences? Do you think that's acceptable to have this kind of oscillations around that temperature that we want to get? Well, no. In real life, there are scenarios that you can, and we have come across over the past 100 years. We have overcome these difficulties, and we have devised methods to overcome this difficulty. This on and off switching is rather can be controlled with PID microcontrollers in real industry. So PID, P stands for proportional, I stands for integral, and D stands for differential. All right, so you calculate in those controllers the desired temperature and the actual temperature. You find their difference, and that's called the error. Okay, so you calculate the rate of change of the error with respect to time, and that would give you the differential, and you calculate the integral of the rate of change with time. That is the total area under the curve. If you're not familiar with the integration in a nutshell will give you area under the curve. So I'm not going to go into details on how these processes work, but my point of this is that you should be familiar that this integration and differentiation has real life applications, and it will run the temperature and the processes in nuclear plants or in many different processes. It will make the change and the process run much smoother. As you see here, that blue line, yet there is a tiniest bit of overshoot of a few, maybe half a degree there, and within a few microseconds, the oscillation comes down to a smooth path where the desired temperature is at 51, for example, in this bottom left graph, uh, and so on and so forth. So, of course, we wouldn't be going anywhere near such processes, and we're not going to be discussing theory into the PID microcontrollers. The point of this is that for you to know that it has real life applications. All right, so with all that said and done, let's focus on the prior knowledge test check, and please pause the video here and have a go at these questions, and then I'll play the rest of this video and I'll show you the answers. Okay, so by now I hope you have had a go at these questions, and the first question is basically just asking you to find the gradient of these lines. Alright, so change in y divided by change in x. You see the first one has gradient of 5 already. I can look at the graph and see you go up by 5 and across by 1. That's why. The next one has you fall down by 2 units and you go across by 3 units, so that's 3 over 2 with the negative sign, and or rather sorry 2 over 3 with the negative sign. And the next one, you draw yourself a little right angle triangle. You say it looks like we are going across by 6 units and up by 2 units, so 2 over 6 is 1/3. And the next one, you just applying for question 2, you applying your index rules, your knowledge of index laws. X to the power 10 is the first one. Second one is x to the power 2 over 3. And the next one is x to the power 5 minus 1 makes it, minus 6 makes it x to the power minus 1. And the next one is a little complicated, 2 minus half and multiplied by half. So that's 3 over 2 and times by half makes it 3 over 4. I'll show you the working out in a minute. So please have a go at these questions. I'll show you just briefly where this question was somewhat complicated. So x power of 2 inside we replace the square root with a power of a half outside the bracket, and under the bracket we have 2 minus a half, which is 3 over 2. 3 over 2 times a half is 3 over 4. Okay, so here for question 3 we are applying the equation of a straight line rule. We learned this in chapter 5. I hope you still remember that. And you calculate the gradient from two coordinates by taking the difference in y divided by difference in x. Alright, so I hope you've had a go at all these questions, and without further ado, well, this last one actually involves a perpendicular line, so you say perpendicular to 2x is negative half, gradient is negative half, and you use the equation of a straight line formula, which I've put on top of the page to figure out the perpendicular line, the equation of perpendicular line. So I'll see you in the next video.